So in this video, we are going to be looking at the ranking task example for average velocity. So in it, it asks us to rank the average velocity for these graphs from least to greatest over the time interval given. So let's start off by reminding ourselves what average velocity is. So average velocity is equal to the displacement or the change in position over the change in time. And so we're going to need to know two things to be able to rank the average velocity. The first is the displacement, and the second is the time. So let's look at the graphs and let's look at the time axis or the x-axis. You'll notice that all of the graphs end at 10 seconds. So we can compare all of these average velocities by comparing their displacements, because if the denominator is constant, since the time interval is constant, the greater displacement is going to result in a larger average velocity. So let's next remind ourselves what displacement is. Displacement is the change in position or the final position minus the initial position. So for A, the displacement is going to be, we start from 0 and we finish at 20. So 20 meters minus 0 meters is equal to 20 meters for its displacement. Then for B, we start at 20 meters and we end at 20 meters. So 20 meters and 20 meters, we have a displacement of 0 meters. For C, we start off at 0 meters and we go to 10 meters. So 10 meters minus 0 meters is equal to 10 meters. For D, we start off at 10 meters and then we finish at 0 meters. So we have 0 meters minus 10 meters equals negative 10 meters for displacement. For E, we start at 2 meters and we finish at 10 meters. So we have 10 meters minus 2 meters equals 8 meters. And then to finish up for F, we start at 0 meters, we go up to 10 meters, and then we go back to 0 meters. So our final is 0 meters, our initial is 0 meters. We have an overall displacement of 0 meters. And since the time intervals are the same, to be able to rank the average velocities, we now just need to be able to rank the displacements. So starting off with the smallest displacement of negative 10 meters, that's D, so that's the smallest. And then moving up, we have 0 meters for F, 0 meters for B. Moving on, we have 8 meters, which is E. And then we have 10 meters, which is C. And then finishing off, we have 20 meters for A. And now to wrap up, our reasoning for this ranking is that since the time interval is the same for all graphs, the larger displacements give larger average velocities.